Hello everyone, welcome to my presentation. My name is Alex Leong and today I'm going to be presenting on how one could repair a corrupted MongoDB shard. A little bit of background about myself. I'm a career database administrator and engineer for over 20 years. I've worked on Oracle databases at the beginning and then moved on to Mongo and other NoSQL databases. Currently, I work for Indeed.com, which is one of the world's leading job search websites. Repairing a corrupted MongoDB shard. Now, while there are many different ways in which a shard could be corrupted, for the purpose of this presentation, a corrupted MongoDB shard has the following error message or similar characteristics. The error says, cannot create collection because we already have an identically named UUID DEE45CDD blah blah, which differs from the donor's UUID of 80199CDA blah blah. Manually drop the collection on this shard. Basically, what it's saying here is that you have this UUID on various collections of each shard, and they are differ. Some of them are differ from the one that is supposed to be the true one. This error will show up whenever there is an inter-shard operation like chunk migration involving a corrupted shard. It means that even though the corrupted shard has the exact same collection name as the others, however, its underlying UUID value is different. If you were to run the command db-get collection infos on each shard, you will see the UUID values of the collection. But the question is, how did we get into this situation to begin with? How do we get into this situation to begin with? Maybe somebody dropped a collection within a shard and tried to recreate it from a Mongo dump. Maybe somebody performed an incorrect restore. Either way, it is a problem which we can fix, hopefully without too much pain. So this last sentence here, manually drop the collection, which is very worrying because it suggests to manually drop the collection and losing all your data. The thought of having to recreate the entire sharded cluster from scratch inspired me into researching if there is another way we can fix the problem. Just a heads up, this presentation is slightly diving into running some Mongo commands to fix the problem. We are going to be talking about shard and chunks within a sharded cluster a lot. However, and in summary, the steps involved are actually not very complex and conceptually simple. I'm going to show you 3 examples whereby a chunk-related operation ends up in failure due to the differences in UUID values. In the next few slides, shard A is a corrupted shard. This means that the collection in shard A has a different UUID when compared to the UUID value in the rest of the cluster and the one listed in the config server. Shard A's UUID has a prefix of 8019CDA-, and shard B, which is the other shard which I'm using in my presentation, has a prefix ID of DE45CDD-. So here, when we try to move a chunk that was residing in shard A into shard B, we ran into this error. Data transfer error, migrate field, invalid UUID, cannot create collection, and so on. You see it's mentioning the UUID values here. And then the suggestion, which is manually drop the collection, as we discussed before. Next example, when we try to move a chunk into shard A, which is already corrupted, we ran into a similar error. Data transfer error, migrate field, invalid UUID, cannot create collection db-cats because we already have an identically named collection. Again, you see the UUIDs here and it's very similar error message. And then finally, when we try to do a move primary, with the primary shard was in shard A and we attempted to move the primary shard to shard B, we encountered the same error. The sharded collection, again, you see the UUID as being the problematic error. Therefore, in summary, you cannot perform any move chunk or move primary operations. Hence, any attempts with chunk migration and balancing operations all ended in failure. Before we go into fixing the problem, here are the good news and bad news about this situation. The good news is that the shard is still readable, writable. That's right. The shard that is supposed to be corrupted, the applications can still read and write onto them. It could go on for weeks before the problem shows and operations continue to appear normal at first. So meaning that as long as there's no movement of chunk migration, everything appears normal and you may not even notice it. The bad news is that the shard size will grow indefinitely eventually, and chunks cannot migrate into or out of the problematic shard, as we just saw, and ultimately will result in jumbo chunks and imbalanced shards. You can simulate what we are about to do here in a test environment by following these steps. You just make a copy of the collection, log in directly to the shard first, make a copy of the collection, drop the original collection, and rename the collection copy to original name. Then it makes the collection to have a different UUID from the standard ones. You could afford it, invest some time into preparing the steps and scripts necessary to deal with this proactively, so you are more than ready to deal with it within a real production fixing time frame. The last 3 points here is just my suggestion as a DBA. It's really up to you how well prepared you want to be, as it could save time. Normally available solutions. When you are in this situation, here are a few solutions you can consider. Few things can be worse than having to drop an entire collection. Imagine you have hundreds of shards and having to drop the collection due to this issue. It would be very painful at best. Restore from a backup. You can do that. This takes time, however, but obviously if you have a backup handy, you can take that route. However, but if the batch shard has been around for months, chances are you may no longer have a backup of healthy, uncorrupted shard. Even your backup will have this same problem, assuming that you keep your backup like for a month and this problem has been existing for more than 2 months. So in summary, the batch shard can go undetected for months. Repairing the problematic shard. So you have made the decision to go with the steps I'm about to present here to fix the problems. Here are a few things to understand. Make sure you understand completely what you are doing. Only you could decide if these steps are applicable to your environment. I put a disclaimer here, test out these steps for your particular environment and situation first. Always have a backup of the entire cluster in case you mess up some steps. This is to protect against human error. It was a good advice to have a backup. If you recall, within the config server, there is a collection called chunks. This is essentially a map of where each document can be found. Each chunk has a minimum and maximum ranges of the shard key, and any document whose shard key falls within this range would be designated to be in this chunk, logically speaking. As you know, each chunk belongs to one shard. Just as a brief refresher on chunks basics, there are no two chunks with overlapping minimum and maximum ranges. There are no two shards with the same chunk. And it is essential you understand this and keep this in mind throughout the steps. The main focus is on these two steps. A, saving documents to a healthy shard that entails a physical operation, and B, manipulation of the map chunks collection that entails a logical operation. And also, while the problem is with the UUID of the collection, in my presentation, it is assumed that the chunk ranges themselves are still intact, healthy, and uncorrupted. Okay, so We're on slide 11. Okay. So this is the first step. The first thing to do is to confirm which shard or shards is corrupted. We determine this by comparing the UUID of the collections collection found under the config database against the UUID value of the affected collection on each shard, one at a time. So you can run get collections here, DB collections find here, and then you can do a DB get collection infos here at the shard level. We'll show you the UUID, the difference. It differs from the one that is in the collections collection. So as you can see, shard A's get collection infos return a different UUID value than the one in the collections collection. Please keep in mind there could be more than one shard where the problematic collection could have a different UUID, in which case we would handle them one shard at a time. Now, every shard has one primary shard. Every sharded cluster has one primary shard. This is where the non-sharded collections reside. If the collection in the primary shard has an invalid UUID, we first need to move the primary shard that is unhealthy. We first need to move the primary shard to a shard that is healthy. First, since we cannot use the move primary method, we will just update the database collection by setting the value of a healthy shard, like in this example, using the update one command. So when I do a database, DB database find, I show that shard A is my primary shard. And since I cannot do a move primary operation, I go into the database collection and run an update one. I update primary shard A to the value of shard B. And then when I do find databases again, it shows me shard B is a primary shard. Step 3. If the unhealthy shard is in draining status, we clear the draining flag from the shard collections as shown here. You do this by using the update one command. So pretty straightforward. You see shard A has got a draining status. You just unset the draining field so that it becomes a null. Step 4. It is always a good idea to know how many documents and how many chunks we are dealing with. These many documents, physical, and chunks which are logical entity need to be moved out of the unhealthy shard. So here's some commands you can use to analyze your situation. This query shows you the individual chunks with minimum and maximum ranges and the shard where each chunk could be found. So again, it's a good idea to have an idea of where the bad shards are, where the bad chunks are residing, and before you prepare for your operation. Step 5, preparing to delete documents from bad shard and insert them into an existing healthy shard or a new shard. So if you have to create a new healthy shard to perform this operation, just because you do not have any more healthy shards which you can use, you just run a small move chunk operation into that new shard, and the collection with the right UUID would be created implicitly and automatically. So here's a tip: always find the smallest chunk that has the fewest document to this one-time manual move operation. What happens when you do this is that the collection is going to be created on the new shard, and we'll have the correct UUID value. Step 6, delete document from the bad shard, insert them into an existing healthy shard or a new shard. First, we perform the physical part of the operations. We export the documents from the collection within the shard. We then import these documents into a healthy shard. Next, we physically remove the documents from the bad shard. At this point, if an application tries to read a document from this shard, you will not be able to find it. The router still has the old map of where the documents are, which we have just deleted. Step 7. Now, this is arguably the most difficult step and has to be executed carefully. In this slide, we perform the logical part of the operations. Remember earlier on, we have the physical and logical. So here we are doing the logical part of the operations. We update the chunks collection such that the old shard value is replaced by the new shard value. We also clear the history field value. So there is if you look at this query here, there is a history field value, there's a shard field, and there is a last modified timestamp. Last mod timestamp. So we clear the history field value. The field there's a field called last modified and its timestamp value. If you were to run a get indexes on the chunks collection, this is actually a unique index. What I do is get the maximum timestamp value within the chunks collection, and for each update statement, I add 1 to the timestamp value. So for example, you can see here I have timestamp 40, 41, 42, 43. These are update 1 statements on each individual shard. Excuse me. As there are only a handful of chunks here, I could construct this update 1 statement manually. In practice, you are likely to be dealing with hundreds, if not thousands of chunks, in which case you would want to use a JavaScript or similar to generate the update 1 statements. You would batch them together to be executed. Once again, it is not a bad idea to back up the chunks collection in case you make a mistake and mess up the updates. So in my example here, I'm running the update 1 command on the 4 separate chunks that originally belong to the corrupted shard A. Once you're satisfied, restart the routers and all Mongo S. Here's a slide just to show you the last modified timestamp values. You should start the Mongo S once you're ready, when everything is good. After you are done, validate your work. Run some queries, make sure you are able to locate the documents. The final step. So now that the corrupted shard is empty and devoid of documents and chunks, we can safely remove the shard. You are now free to migrate chunks into and from the new shard, which you were unable to do previously. Oops. So this shard A has got no more documents in it. There are no more chunks in shard A. You just remove them using the regular remove shard command and it will work. So steps are now completed and problem is solved. So thank you. I got a few minutes to take on some question and answers. Let me go back to the main screen to see if any questions that I can answer. Okay, no questions so far. You have any questions and you want to try this out, feel free to send me an email. I'll be willing to give you more information. Yes, definitely it's good to know. Thank you, Matt. It is something good to know. We do not want to, imagine you have hundreds of shards and billions of documents. You do not want to drop the collection to solve the issue, where you can just go through these few steps. Although a little bit complicated, but it's not that bad really. So with that, I end my presentation. Just give you back 10 minutes to go. And thank you for joining. See you later. Thank you, everyone. Eduardo, any chance this presentation will be available later? If you want the slides, I can send it to you. Shoot me an email and I can send them to you. Eduardo, thank you. Okay, enjoy the rest of the day. Bye.